All right, yeah, I'll get started. So welcome everyone. Today I'll be speaking about CAP74, which introduces host functions for the BN254 pairing friendly curve. So as you may know, Stellar already has host function support for the BLS 12381 curve, which was chosen over BN254 due to growing support for it and security. But we've gotten ecosystem feedback that there are existing use cases that rely on BN254, and adding native support for it will make it easier to implement those use cases on Stellar. The other option would be to adapt those use cases to use the existing VLS host functions, but that would be prohibitively expensive in some cases. So the main part of this proposal is that it adds three host functions, G1 add, G1 mult, and a pairing check, which gives us parity with the BN254 precompiles in the EVM. Now, there have been some discussions about extending this, in particular, adding a host function for G1 multiscalar multiplication, but this proposal doesn't include that. At the moment, we're just trying to support the existing BN254 use cases, and this should be sufficient. And for any new use cases, the recommendation is to use BLS. The cap also specifies new cost types for the BN operations, which are similar to the cost types that we added for BLS. They're just a subset because BN has a subset of host functions. And yeah, it's a pretty short cap. We also define the field and groups. And yeah, are there any questions? If there aren't any questions, Tomer's typing. Yeah, it's a pretty straightforward cap. If anyone has any questions, you can tag me on Discord, and we can have discussion. But if not, I'll pass it off to Jay to discuss adding host support for Poseidon hash functions.
Can you hear me?
Yeah, I can hear you, Jay.
Okay, wonderful. Yeah, great. I just want to add on what Sid just talked about. So yeah, the ecosystem, technically they could use all these BRS functions, but in the proving framework, including like the circuit, like switching those curves off, it's in reality it's more challenging than we thought. It's not just a simple curve swap, but sometimes those protocols can be evolved. The circuits have to be recompiled with different curve, and then there's also different type of issues with different like proving systems support one curve versus another. So BN254 is mostly for backward compatibility, and also we've also added a Soroban example of importing the BN254 inside the Soroban contract, which works, but it takes, I think, like 500 million instructions to do one pairing, so that is also prohibitive. Just wanted to point out these two specific rationales on why this is needed. Cool. Yeah, I will start on, yes, thank you, Anoop, yes. So the Poseidon hash function has also been one of the requested primitive to add into Soroban. So I've recently just looked into this. I don't have a cap yet, but I will lay out what I found and sort of the different approaches, like informally here, and I'll work on the cap. Probably be ready in the next couple of days. So yeah, first of all, why is this also needed? In the proving, in the DK application, the commitment scheme is a lot of commitment scheme is hash based, meaning you hash something and then you prove that this thing has been hashed without revealing it. So the hash function is critical, and then for the hash function that's used is also important in terms of the performance of the prover side. So from what I understand, not expert, but from what I understand is using the right hash function like Poseidon can reduce the number of arithmetic the arithmetic gates, the arguments, by an order of magnitude, like 2 orders of magnitude. So this is a fairly big difference. That's why most of the like the circuits use these field-based hash function, and Poseidon 2 are 2 of the most widely used ones. So the next question is, why do we need to support in the host? Although the proof is generated off-chain and the verification of the proof is doesn't involve hashing, the hash is needed because some applications need to maintain, for example, a Merkle tree of different coins, for example, and then to prove the coin's existence, they can prove without hashing, but to update it on chain or any kind of a state that involves hashing to be proven, it needs to use a hash to update. So to be consistent, we need to make sure that the hash function that's being proven is same hash function as what's being used for contract state update. So that's kind of a big overview of our rationale. And Poseidon functions, these are not one function. It's rather a family of functions, or it's an approach that based on sponges, and then ways to connect these sponges to provide different permutations with different input. So it's fairly generic. You can, in terms of you can plug in different parameters. Like for example, if you require a higher security parameter, then the round parameters would be larger, and also depending on how many inputs you need to hash at once, also how many output, the throughput, the number of rounds needs to be adjusted. So in the Poseidon paper, there's different implementations of different versions of Poseidon given on the requirement as well as the underlying field. So here the primary field we have to support for compatibility is BN254 and also BRS 12381. So that's a two requirement, and based on these requirements, some of these parameters can be decided, but some of them are still can be, some of them can be choices. So we need to really decide what level of flexibility we want to support it with. So in this discussion, the discussion thread, the last post, I've laid out the 3 approaches that I feel we could support it. So these are in terms of from the most high level to the most low level. So number 1, we support it as hash functions directly. So for that, we will support Poseidon 2, and the 2 curves. And then, so yeah, I think this is the most straightforward one. But the limitation is that we need to kind of decide on the parameters internally. Like there's a so in the Poseidon paper, they describe how to choose these parameters, and they choose it. Well, they provide a script to how to generate these parameters and on guideline on how to choose them. And in reality, from what I know, it seems like different applications sometimes generate their own parameters. I'm talking about these internal like round constants, like these matrices. So if someone from another ecosystem that generates a proof with a different instantiation of Poseidon, then potentially here we could not support it. So there's a little bit of compatibility risk. We have to decide But I think for this one, most parameters are fairly straightforward. And then we need to make sure that the major prover, the major prover can be supported, like the circum or NOR, and we just need to make sure that whatever parameter we choose is compatible with major ones that we wanted to migrate to Stellar with. So that's number one. Number two is to expose the internal Poseidon building blocks. So as I briefly mentioned earlier, the Poseidon hashing is a sponge-based block cipher. It consists of absorbing the input, permuting them, and then squeezing them. So one of the ecosystem member, Antonio, suggested that we could support the generic interface to provide these, and then users can just choose the parameters, choose the security parameters, the field, and all that. And then we can expose these options through the SDK. I like this approach, but I think it's maybe a little bit, it involves a little bit of figuring out the requirements for the libraries and then the level of details we wanted to expose, how to expose them to SDK. I'm not expert in this part yet, so I will say that this one right now, I would say this is a less favorable option. And for I think one of the main advantage for this one is that Poseidon and Poseidon 2, they use very similar interface. So potentially this one is more cleaner, that we just support this, and then the two different variants can be supported like more uniformly. Doesn't add complexity. Yeah, I think, this requires the user to understand what they're doing and how to instantiate the hasher with these options. I think I'll also talk about number three, because I think exposing the host function, exposing the hash function is the most straightforward approach, but in reality, it's just the different parameters we can support them all. But then with the internal building block, it's possible that we could give more flexibility. But I think that's kind of the main rationale. But in how to do it, we have to think it more carefully.
I wanted to say that for approach 2 and probably 3, it's not like we have to put much burden on the users. It's just that we can build SDK functions, right, that do the same hash functions, for example, as you have in option 1, but there is a huge benefit of not introducing like combinatorial explosion of the code types into host, which I think is a really bad property of approach 1, right? It seems like instead of just setting a few cost types, we need a lot of them, and if we wanted to do something more complex, we would need even more, and this is, I think, a lot of maintenance burden and a lot of complexity in the protocol, which I think kind of would be nice to avoid. So I feel like these parameters could be implemented in the SDK, so user complexity would remain the same. The only question is really performance at this point.
Yeah, I disagree on the cost type part, because I think doing 2 and 3 can reduce the amount of cost types potentially, because these are just
yes,
3 building blocks, and then the
parameters
just affects.
To be clear, I totally agree with you. I'm saying that I do not like option 1 because in option 1 we need the cost type per hash and per whatever curve and per arity, which is an argument of the function, which is what I refer to as combinatorial explosion, right? We have like 3 different inputs to that. So I think we are on the same page here. I agree that we probably want to have more limited and like number of cost types that can be used as building blocks.
Yeah. And by the way, also the rarity, I think for a minimum, we need to support RT2 to support the Merkle tree or binary Merkle tree, but we fairly certain we don't need 4 right now, and then 1 maybe. So at a minimum, maybe just a RT of 2, but I'll need to confirm it if this is just what we need.
Yeah, I still feel like it is like a really hacky design, right? Like we have a host function that has an argument, but it can have only like a couple of values. So I don't know. I would really try to stay with the building blocks and do work on the SDK side if it is feasible from the instruction count standpoint.
Yeah. So number 3 is going a step further to do this without providing any Poseidon host functions, because the algorithm itself is fairly, dare say, straightforward. It's more like applying arithmetics repeatedly in iterations. So in theory, most of the heavy costs are in the field arithmetics, which we already provide for BRS 12381, and then for BN, we are going to provide them. So the question is, can we just do this on the guest side? So I did a bit of experiment. What I wrote, hash 2 takes about 17.6 million instructions. This is trying to do the optimized implementation and all. I think it's with the current implementation, that's the best we can do, and out of which only around 3 million other crypto arithmetics. The main reason is that to do every arithmetic, you have to go round trip to the host and then to do the byte to internal representation conversion, and then internal type for efficient arithmetic requires, if I remember correctly, it's a Montgomery form. So it needs to do some arithmetic to convert the numbers into some form that's efficient for multiplication or multiplication or division, for example. So there's quite a lot of these overhead. So the thought process is, if we can bundle these into some more efficient field arithmetic functions, such as dot product and matrix multiplication, is it possible that we can reduce that cost? I don't have a straight answer for that, but my intuition is that we can reduce that significantly, but maybe not to the level that we require. For reference, to hash a Merkle tree of 1 million entries, we need 20 hash operations. So this would require at least 10 to 5 times reduction of that number. So I think we can, reducing these operations, it's doubtful that we will get close to the upper bound that we're shooting for. A bit of reason into that is because even though we can provide the matrix multiplication, these matrices are fairly small, like 3 by 3. So we're not bundling 1,000 operation into one. We're just bundling 9, and then the rest of it is still WASM code and these loops, and which will still have significant overhead. That's why I feel like this approach, even though it's more attractive, it probably wouldn't work well, and also it will require the user to handle their Poseidon implementation. So overall, I think, in my opinion, number 1 is probably the best option to support it today. And then we need to think more about these parameters and choices.
Any numbers for option one? Like how much more efficient is it?
Yeah, in number 3, I added up all the metered cost for arithmetic. They are about 2.5 million. So I would say number 1 would be much more closer to that. There's still like some like extra costs of like memory allocation, like the conversions are still a bit, but I would say it will be much closer to 2.5 million. Yeah, good point, Thomas.
Are the numbers in 3, like when you say optimize, is that like what do you mean by that? Is that like a native call that you tested? The 17
No,
point
it's
million?
it's not a native because it's WASM contract, so it's basically implementing Poseidon cache in WASM, but calling the host functions for BLS scalar add, multiply, and these functions. Optimize just means that I tried what I can or what I know to make sure that these calls are all necessary, and then we're not wasting like unnecessary conversions and things like that.
Okay.
The cost between 1 and 2. Yeah, I don't know in terms of CPU cost, I don't know how much they will be different. It's more like the complexity and the maintenance. So I would imagine if done properly, they will be pretty similar in terms of performance. But it's more like the question of, do we want to expose that level?
Again, for the complexity, I get the argument. Like I think really complexity, as you said, can be moved on the SDK, right? So I think what is important here is protocol complexity, and I feel like 1 is more protocol complexity just from the standpoint of maintaining the permutations of different inputs. So if 2 is really, it's Unica has the same stuff. So yeah, if you had a number for 2 and if you knew that it's not significantly worse than 1, then I feel like 2 is a much better option.
Yeah, I haven't done enough exploration in that direction yet. Yeah, I'll try that in the update. Yeah, but even for 2, we need at least Poseidon and Poseidon 2 because these sponge implementations are different. So that we're talking about, like at least maintaining like six of these functions potentially.
Yeah, but it just feels much better still because it's like at least finite and it covers like all the cases, right? Yeah, so as Nika points out, like if parameters isn't hard coded, so something new needs to be done, then anyone can do it as a guest layer.
Okay. Yeah, I'll do a little bit more exploration to 2 and if I'll update them on the thread. Yeah, Alex, I think that's a agreement. I think 2 is more flexible. It's just a little bit of complexity to do it right. Yeah, I think in option 2, even though we expose these primitives, the internal parameters would still have to be, like, I think these interfaces don't let you specify the security parameters, like the round constants matrices. So yeah, one other thought I had was, should we expose those, or should we like let the user initiate the hash with set of parameters they want, and how relevant would that be for most ecosystem? But I haven't figured out answer to that yet. So there's potentially doing 2 with maximum interoperability could be more complex.
Different parameters, like, would they impact the runtime, or are they just
No, it's just
different numbers?
no,
to put
not
into
runtime. Yeah, it's different. It's just different hash. The output will be different, but the runtime is just yeah, the width of the inputs and the number of rounds. So yeah, runtime, I think with number 2 we can have that metered with like per iterations, but the security parameter is just the choice of yeah, like the choice of hash states that will provide different outputs.
Yeah, I agree. Like, if we add a capability to provide configuration and it does not change host complexity much, then we should do that. Because
okay,
from the hosting point, I would be concerned about the metering, but since we can meter it all the same, I don't see like why would pass in an additional vector or something as an input would be introducing too much complexity. Okay.
yeah, yeah, so, yeah. I think mix 2 would be a good good solution for interoperability. I'll spend more time on that. I think I saw someone typing.
Hey guys,
Hi, Yan.
can you hear me?
Yes.
I'm in a bit of a loud environment, so hopefully you can hear me. Yeah, so I joined in the middle, so maybe I missed some things, but I think I kind of understood Jay's proposal with hard coded option and an option that enables us to configure MDS and round constants parameters. Seems to me that the configurable option is a good way to go, because that still optimizes the hash function itself to run fast after initialization, but enables some flexibility. The one thing I think we need to ensure is, and I don't entirely understand how it works, is how often we need to initialize the Poseidon hash, because initialization takes like, let's say 4 million titles instructions. So I think it would be good to understand whether, say, to deploy Poseidon as a separate contract, and then call it, whether the initialization only occurs once the deployment is done. So those are details that I'm less familiar with. So as long as we can guarantee that the initialization of the hash doesn't happen very often, I think this configurability is definitely an advantage. Yeah, I don't know. Any specific questions? What's the complexity when the initialization step? So actually, Jai was looking into that as well. Yesterday, he was looking into Poseidon implementation. From what we saw, Tom, when we did it review, when we checked the budget, it seemed like it's around 4 million instructions, and then the hashes themselves are around 20 million for the everything running in Wasm. That's yeah. As long as, for instance, those 4 million instructions happen in my application once a deposit, that's not too bad.
Sorry, could you repeat the part? What's the 4 million instruction?
That's the construction of the house.
Oh, okay. Yeah. Yeah, I think I'm thinking like if it's like a contract, like every contract has its own the seed for like the RNG, for example. Similarly, every contract can set its own the state, and then they can, once it's set, it should be yeah, that should be the initial cost. That yeah, I'm not also familiar. I'm also not very familiar with the internal working of like these hashes, so I need to look a bit into it. But I imagine the initialization is just one time and absorbing. Yeah, and then you need to, and then to use it, you have to absorb it first. So that would be like probably based on the number of inputs.
Yeah. So the initialization is just like reading checking the constants. It's not a stateful hash or something like that. So as long as that's done, you can hash.
Yeah, that's right.
Yeah, I guess it's per. No, it can be per con. It can be per contract life. That's a good question. But then you need to serialize it somehow between illustrations, or if you're invoking a method from another contract, that then I guess you can just keep invoke. It's getting cached, and we can keep invoking that. But hey, I'm talking here about details that I'm less familiar with. Okay, but yeah, I mean it's not per invocation of a hash. It's per however long it can be. Questions. I have a Tomer, I have a question about what you wrote. So, why would it matter whether other ZK projects have different configuration matrices, apart from unless you want some interoperability between different projects and different chains? Other than that, we can speak our own parameters. Sure, makes sense. I mean, it's there's definitely an advantage to having the same parameters based on your Ethereum. Yeah, more future proof for sure.
Yeah, I think it makes sense. Yeah, allowing the constants to be overwritten for different chains and different projects. Yeah, makes sense. Yeah, good point. Thanks, GPT. Okay, so I think that's seems like that's the main questions and concerns is interoperability and the flexibility of parameters. So yeah, I will look into option 2 in more depth, and then I will update that thread, and then CAP will follow. Is there any other questions?
I guess also to add, I guess it would be good to look at the parameters of the Circom lead, the standard Circom library, and see what they correspond to in terms of whether they correspond to a specific project. Because so far I've replaced them with something that works for me and is interoperable between what it is that work in a Circom and Rust, and creating my own trait and my own instance for Circom. So that's overriding the Circom library. If we can go back to the standard Circom library and use the parameters, that simplifies things.
Oh, okay. So did you say you changed those parameters in order to?
Yeah, basically on both ends, both on Circum, on the Rust end, basically parameters that I took from Poseidon implemented for Circum, but not. I need to check if it comes on the standard Circum library or from another library for Circum that I found the third-party library. I need to double check that. If we could speak to the default Circum with parameters, that would be good for them.
Yeah. Okay.
And they probably correspond to other projects as well.
Yeah. So perhaps like supporting like a couple of, right? It's like supporting like a default set if it's not overwritten, like default to like a Circom or something. Cool. If no other questions, I guess hand it over to you, Bri, if you want to close the meeting. Okay, wonderful. Thank you all. See you later.